Welcome to the Chapter 5.3 lesson video. Today we're going to be talking about a new identity, the cosine sum and difference identity. All right, so this is a new identity. We'll talk about it. We'll kind of figure it out. There are other sum and difference identities that we'll talk about a little bit later, but we start with this one for now. All right, so learning targets today are being able to use something called cofunctions. We talked about that before. That'll be the last part of the lesson. But the main thing is using the cosine sum and difference identity to find the cosine different values of different functions that we wouldn't normally be able to find. So let's go ahead and dive on in. All right, so first off, quick question, and I'll kind of elaborate on this real quick. I'll do it for us real quick, and we'll see whether it's true or not. It says, does the cosine of A minus B equal the cosine of A minus the cosine of B? Hint, it does not. All right, so it does not, but we'll go ahead and we'll show that it does not here first, just to kind of help put your mind at ease that I'm not making stuff up. But yeah, let's go ahead and look at this. So the cosine of A minus B, if A is pi over 2 and B is 0, we can check this. So we'll do the cosine of pi over 2 minus 0 and the cosine of pi over 2 minus the cosine of 0. Well, order of operations here, this first one, we have to do the pi minus 2 over 0 first. So we get the cosine of pi over 2, cosine of 90, which is 0. So we get 0 right there. 0 equals, and then on the other side, we have to do them separately. Order of operations, we do the two cosines first, then we'll subtract them. So cosine of pi over 2 is 0, minus the cosine of 0 is 1. So what we have here is a statement that says 0 equals 0 minus 1, which is not true. 0 does not equal 0 minus 1, 0 equals 0. So that is not a true statement, which means that this initial statement is incorrect. Okay, so we essentially just disproved that this statement, that this identity is true by testing something in it. So if that is not how cosine sum or difference works, if you can't just take the cosine of one thing and the cosine of the other, how does it work? So here is our new identity. These are our cosine sums and different identities. Once again, these are identities you're going to want to try and memorize to the best of your ability. Cosine of A plus B, so this is a little weird at first, but you'll get used to it. Cosine of A plus B is the cosine of the first thing, A, times the cosine of the second thing, B, and then it's an opposite sign, so minus, because this was plus over here, so it's minus the sine of the first thing times the sine of the second thing. So that's if they're adding here. If they're subtracting here, it's the cosine of the first thing times the cosine of the second thing, plus, remember, opposite sign, plus the sine of the first thing times the sine of the second thing. All right, so if it's cosine A plus B, it's a minus sign, and you do cosine of the two things minus the sine of the two things. And if it's A minus B, then you do cosine of the two things plus sine of the two things. It's always this order: cosine then sine, minus, plus, opposite sign, and you do both A and B for each of them. All right, we'll not bother checking them. That might be something we go ahead and do in our live class just to kind of drive this point home. But let's go ahead and let's see what we can use these for. All right, so here's what we have. We have two identities. We have cosine of 105 degrees and cosine of pi over 12 degrees. Now, neither of these are reference angles that we are necessarily familiar with. They're not our kind of traditional reference angles. So what we're going to do is we're going to rewrite them as two angles that we do know how to evaluate, two things that we do know how to evaluate. We'll rewrite them as two angles like 30, 45, 60, 90, 180, 270, 360, those ones. And once we've rewritten them as two angles we do know, then we can use our cosine sum and difference identity. So let's start with the first one. The first one's a little easier. We'll go ahead and rewrite 105 degrees. We're going to use two angles that we do know, that we can evaluate, that add up to 105 or subtract to make 105. So I'll just do the easy, kind of hopefully ones that come first to your mind. 60 degrees plus 45 degrees. There you go. 60 degrees plus 45 degrees is probably your best bet, starting right off the bat. So this is now cosine of 60 plus 45. So hey, we can use our identity. So we can go ahead and separate that out and rewrite it as the cosine of 60 times the cosine of 45. Opposite sign, since it's a plus up here, we're going to make it minus the sine of 60 times the sine of 45 degrees. Now, it's been a little while. Hopefully you remember these from last semester, how to evaluate them relatively quickly. If you don't, definitely something you want to brush up on. Cosine of 60 is 1/2. Cosine of 45 is root 2 over 2. Minus sine of 60 is root 3 over 2. Sine of 45 is also root 2 over 2. You can multiply these together. You just multiply straight across the top, multiply straight across the bottom. You end up with root 2 minus root 3 times root 2 is root 6. On bottom, 2 times 2 is 4. And this is our final answer. Root 2 minus root 6 over 4. You can't simplify that any further. So hopefully you notice that this is a bit different than what we've done before. You have an angle, a reference angle that you don't necessarily know. You break it into two you do know. You rewrite it using the identity, evaluate each piece, simplify your answer. We can also do this in radians. Now this is a little bit trickier in radians. So you might need to do a little bit of side work off to the side. I'll do that here in red real quick, and we'll use that. I have pi over 12. So I have to figure out a way to make pi over 12 out of angles I know. So I have 1/12. So if I have an answer that's equal to 1/12, okay, obviously denominator 12 is not something I know, but let's try and think of something to make a 12th that'll be a little bit easier, maybe a little bit more helpful for us. So what are two things we can subtract to make 1/12? Well, we could subtract maybe 4/12 and 3/12. All right, so 4/12 and 3/12. That would make 1/12. Well, you might say, well, why would I pick those things? Why would I know those? And it's a little bit of an instinct thing. It's a little bit of something that you already know from practice, hopefully. But 4/12 minus 3/12, the reason you might want to do that is when you simplify these two things, 4/12, well, that becomes 12 divided by 4 becomes 3. And 3/12, that becomes 4, 1/4. So what we could do is we can rewrite this cosine of pi over 12 as the cosine of, let me change the color on my pen, excuse that, the cosine of pi over 3 minus pi over 4. So we're going to rewrite that pi over 12 as pi over 3 minus pi over 4. And we know that because we kind of worked a little bit backwards here. We know pi over 3 minus pi over 4 is going to become 4 over 12 minus 3 over 12, which would leave us with the 1 over 12. Okay, so we go ahead and we rewrite it. We expand it using our identity. So we say we have the cosine of pi over 3 times the cosine of pi over 4 plus, because it's an opposite sign, and up here this was a minus sign, plus the sine of pi over 3 times the sine of pi over 4. All right, we can evaluate each of these now. So remember, pi over 3 is a 60-degree reference angle. So cosine of 60 is 1/2. Cosine of pi over 4 is 45, so that's root 2 over 2. Plus sine of 60 degrees is root 3 over 2. Sine of pi over 4, 45 degrees, is root 2 over 2. So this is a really similar looking answer. There's a key difference though. We have root 2 plus root 6 over 4. And a lot of these cosine sum and differences end up having very similar looking answers to each other. But there we go. So what you're going to do is you're going to take what's given and you're going to try and rewrite it in something that we can evaluate. 105, I don't know 105, but 60 and 45s, those are good to go. Pi over 12, I don't know that, but I do know pi's over 3s and pi's over 4s and pi's over 6s and pi's over 2. So I'm going to try and rewrite it in some form of pi that is working for me. Now, the way I did that is I just kind of futzed around with the little bit of arithmetic here. I was like, all right, well, I got 12s, and I could have tried to do 2 minus 1, but then I'd still have a 1/12, so that didn't really work. So then maybe I would have done, all right, well, 5 minus 6, well, 12 doesn't divide by 5, so that's not really good. Maybe I would have done 6 and 5, well, 5 doesn't work again. So it was kind of just figuring out what two things are going to help simplify that 12 away, but also are divisible by 12 and subtract to make 1. So that's where that 4 and that 3 came from. All right. One other thing, and this is something that I'm not going to spend too much time on here in the video, but cofunctions is something we talked about earlier in the year. Every function has a cofunction. Sine has cosine, cosine has sine. Tangent has cotangent, cotangent has tangent. Secant has cosecant, and cosecant has secant. They go back and forth. Basically, what it says is I can change any trig functions from sine to cosine as long as I change the angle on the inside to be 90 minus the original angle. So in other words, the sine of 40 is equal to the cosine of 90 minus 40, or 50 in this case. All right, so I could do that for any sine, cosine, tangent, cotangent, secant, cosecant. This is also where you remember this problem, and it was on the final, and I know some of you guys asked me about it after the final, where we say something like the sine of x equals the cosine of 2x, and you have to say, all right, well, x plus 2x equals 90. That's the cofunction problem. This is just another type of that problem. But one thing we can also use it for is changing between two different trig functions. So say I have cosine, but I really want sine. I can change this to be the sine of 90 minus the original angle, 15. 90 minus the original 15, this is the sine of 75 degrees. Likewise, secant of 37.2, do the same thing. I can change that into cosecant of 90 minus 37.2. All right, so I could change that, and that would become cosecant, degrees. That would become cosecant of, I think, 52.8 degrees. Yep, that seems right, 52.8 degrees. 90 minus 37.2. I can also do it for this tangent, but remember this tangent's in radians, we can see that there, so it's going to change to cotangent, but rather than using 90, what I'm going to use is I'm going to use pi over 2, which is 90 degrees, but in radians. So minus 3 pi over 10. It'll take a little bit of math here. I'm going to need a common denominator, so I'm going to change this into 5 pi over 10, so they're a common denominator. 5 pi over 10 minus 3 pi over 10 is 2 pi over 10. So we'll make this cotangent of 2 pi over 10, which does simplify, so you should simplify that to cotangent of pi over 5. All right, so cofunctions. We can switch from one function to its cofunction. We just have to do 90 minus the angle on the inside. That should be enough to get you started on the homework. If you have any questions, please reach out to me. If you want some more examples or some help, I'd be glad to help you out at any time. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.